Greetings everyone, my name is Viresh Vasnik and today we will be looking forward in this video about the flow over UFO which is in saucer shape, and we'll be looking step by step into it about like the geometry creation which will be explained by me, and meshing which will be explained by Omkar Dhale, and the setup part which will be explained by Dheeraj Chawda, and the post processing and result discussion part will be explained by Murli Krishna Tumma. So let's jump into the video. So first we have to select ANSYS Fluent. Like we have to open the ANSYS. We have to select fluid flow Fluent. Now here we have imported the geometry from the GraphCAD. So to import it in the ANSYS, we have to select, right click over here and import geometry and browse. So you have to open from where you have we have saved it, and this part should be in, like, this file should be in the form of step file, to which if it is in step file, then only it will open in ANSYS step file or STA format. So it is imported. This green tick says that it is imported. Now we have to open it in Design Modeler. So it is opened in Design Modeler. To see our what we say assembly, we have to click here, right click in on import and generate. Now, so this is our body. This is our model which we have selected for the flow analysis. Okay, so in the Design Modeler, once we have imported the geometry, to see, we have to click here on import, right click, generate. So now we can see our geometry which we have taken or we have designed. Now here we are going to create two enclosures. Like we want different domains, so that's why we are going to create enclosures which will be box type, and in question we have to select uniform, and it will be 4 meters. Like according to our model, it is 4 meters is enough for us. So depending upon your model, you should be selecting this cushion size, and here generate. Okay, so this 3D enclosure is generated of 4 cross 4 meters around your imported model. Now we want one more enclosure, one more domain to like visualize the fluid flow. So again in tools, we'll be creating one more enclosure, and here it will be non-uniform, and his x value, positive x value is 150, and negative x value is 30 meters, and these values are taken from one of the research papers which we will be showing it further. And this will be 28.39. All these y and z values are same. Okay, this generate. So we can see we have generated two enclosures around our model. So, and now like we are going to rename it like this. Since it is the inner domain which we have created, let's rename it as inner zone, and this one as outer zone. Okay, now since we have to rotate this geometry, we have to rotate this model to visualize the flow. So we will be applying create body transformation rotate, and we are going to rotate the fuselage. So target the bodies will be fuselage, apply, and the axis, like here axis definition on components, it is already set to 45 degree, you can see, but we don't want 45 degrees. Like we will be visualizing the flow of but not on 45 degrees. Currently we want 0 degrees, so we'll set it to 0. And in here in Z component, it is set 1 because the UFO will be rotating in the Z axis, like which is this axis, Z axis. The UFO will be pitch up, pitch down motion will be on Z axis. So that's why it is set to 1, and other rest X and Y are set to 0. And now here generate. Okay. After generating this rotate, and now we have to separate this two domains which we have created. For that we have to create boolean for boolean 1. Now we have to separate, so we'll be selecting subtract. Now target bodies, first outer zone, apply, and tool bodies will be inner zone, apply. And since we have to preserve, it is asking like do you have to preserve the tool bodies. So yes, we have to preserve the tool bodies, like in the inner zone we have our fuselage. So since we have to visualize our flow over the UFO, so we have to preserve our tool bodies. So here we will select yes, then generate. And now we have to create one more boolean to separate. So the target body here will be inner zone. Okay, wait. Target body, you have to select inner zone, and tool body is fuselage, apply. And here it is asking again for do we have to preserve the tool bodies. So here we will select no, because we don't have to if we select here yes, it will be like we are interested in the flow inside the UFO, but we are just visualizing the flow over the UFO, not inside. We are not interested in the matters happening inside the model. So we are just interested over on the flow over. So we will be selecting here no, and then generate. Okay, so you can see this now fuselage from outside it is subtracted. Now this is ready for meshing. Our geometry work is done. So now the meshing will be further explained by Omkar Dhale.
Hello everyone, my name is Omkar Dhale, and here I will do meshing. So the first part, which is the geometry part, in which we have taken a geometry of an unidentified flying object, that is UFO, from GrabCAD website, is how we took it from other application or other software into this ANSYS software is explained by the Viresh Vasnik, and how we have provided it domain, that is enclosure, is told by the Viresh Vasnik. And after that my part, that is meshing, will be done, and after me there will be explanation about setup and post processing and flow simulation given by the Dheeraj and Murli. So let's get started. So first right click on the mesh in this window. After right clicking we will get these options. So here first click edit option. So wait for some time. So now mesh window is open. I will share the mesh window. So this is the mesh window. Here you can see. Okay. So inside this you can see a small box, and outside is a big box. This small box is the first enclosure for your UFO, and outer box, that is the big domain in which the small box and UFO is. So for meshing, first click here on the mesh part. So as you see, then go to the element size. Here we can give the element size, which will decide over the meshing, how define the meshing we want, or to what factor we want. So here we will took 3000 element size. Because of the student version, we are using this. Let's here take 3000. Let's take here 3000 element size. Okay. So once here element size is taken, click here, click right click, then click right click, go to the hide bodies. So the bigger enclosure will be hide now. After hiding it, click here on mesh, right click, insert, then go to the methods. So here select this whole body, then here apply. Now right click here and go in show all bodies. When you show all bodies, then again follow the same procedure, that is go back to the meshing, click right click, go to insert, go to method. Once you go to the method, now select this the bigger envelope, then click apply, then right click on mesh and generate mesh. So this way you will generate a mesh which have irregular element sizes and shapes. That is, their mesh form is not uniform mesh here. So wait for some time. Here you can see the progress of the meshing. Here the progress is 47% meshing completed on one of the two parts. Okay. Okay, now you can see this is the mesh generated, and this black thing here is our geometry, that is the UFO. Just a minute. So here you can see the shape, the flying saucer or UFO, and the small domain here, and this is the larger. So if you want to make it more uniform or well defined, you can go here, select box, select this whole geometry. Before that, in mesh right click, go to insert. In insert, go to fresh meshing. Now select this whole geometry and click here apply the window down here, and now generate the mesh. So now you will get somewhat uniform mesh. So rather than ununiform mesh, some good mesh will be generated, which will be easy for the our results. So wait for some time. You can see the well quality mesh generated. So this is the mesh. This is our geometry, that is the flying saucer or UFO inside the enclosure. So now we have to give names for the this envelope. So from where velocity of means from where air will come, what it should get out. So like that. So first go to here, select single select, go to the face, click here, click N, which is the shortcut for the selection name, or you can simply right click here and find the selection here, name selection here. So once you right click, there will be create named selection here option. So give here inlet, because the air will be entering from this side. Then this side will be outlet. Now select one by one these sides. 1, 2, 3, 4. So all sides are selected. Make it sure. So once all these sides are selected, give it name as walls, or you can also name it pressure far field. So better it will be pressure far field. What are the spelling mistakes? Pressure far field. Okay. Then select the whole geometry. Sure everything is selected. Okay. So click N. Give it name as the fluid. Press OK. So now you have given name to the every part, or the part which are mostly required. So for viewing which part you have given names, click the plus symbol here at the name selection. Go to the inlet. So this is the inlet, this is the outlet, this is the pressure far field or walls, and the whole section is this, whole block is fluid. So this was all about the meshing part. The further part, that is the setup and the analysis, will be explained by Dheeraj and Murali Krishna. So now go to file and close meshing.
So, hey, I'm Neeraj Chawda, and as my fellow teammate Nilesh has already introduced me, that I will be explaining you about the setup of our UFO analysis. So basically, as he has already been explained, that we have to calculate the flow. That is, we are doing a laminar flow over a UFO in order to calculate its lift and drag at 0 degree, 5 degree and 10 degree of the rotation along the z-axis. So as you can see on the interface of my axis workbench, you can see 3 modules of the fluid flow fluid for 0 degree, 5 degree and 10 degree. So this 0, 5, 10 degree are basically different kind of mesh geometries have been created. So let us first initially start at the 0 degree, and the rest of the procedures for 5 degree and 10 degree will be same as the 0 degree what we are initializing, because only the rotation we are giving is about 5 and 10 degree. So without wasting any time, I will just introduce to your setup. That it will be very interesting to see. So just click on edit button, as the geometry and the meshing is already done by my fellow teammates, that is Vinesh and Omkar. So I will just be in double precision. I will take it as double precision, and the solo process I will be using it as my computer supports 8 course. So I will just clicking on the start button. After clicking on the start button, it will be having taking some time in order to frame your mesh and the UFO what you have created. So it depends upon the mesh quality what you have given in order to take that time. So it will be taking some time. So as you can see, it is the outer domain of what we have created in the mesh and what we have earlier seen. So now let us go on to the starting of the procedure, that is very basic. What we have to do is that we have to scale our mesh. Scale mesh basically means The mesh and the geometry was created in the meters. So we will select here meters so that the solver process or the process what we are doing should be calculating the terms in terms of meter. So I'm just clicking on the scale button below the scaling factor. The scale, I will proceed at my own risk. So, okay. So as you can see, it has computed some of the values. So I will just click on the close button and now check. However, checking the quality of the mesh, as you can see, it has created some kind of, you can see values like minimum. I will just select you for it, so it will be easy for you to visualize it. So as you can see, it has given some values to us. So it is checking the mesh quality and it has completed its mesh quality. Talking about the next, what we are doing is that we are calculating the type of the solver is the pressure-based solver, and the time is steady, means it is a constant time. It is not a transient time that is being changing. It is steady because what we are doing is that we are doing a laminar flow around the UFO. So which I will be showing in the later process of our CFD setup. This general category is being completed by me. So then we move on to the models. So the model we are going in the viscous model. As I said just now, earlier I have said that we are using a laminar model. We are not going to initiate, we are not going to any other, you can say, turbulent flow. If there were turbulent flow, we will have take different models. So what for our analysis, we are selecting it to be a laminar. So I will just selecting the laminar and I will be just clicking on it, the OK button. Otherwise, the rest of things we have to don't interfere in that because it is very for the advanced level. We are just creating a basic model of our UFO that is calculating the lift and drag. Talking about the materials when we go into the fluid. So it depends what your fluid you want to take. As in our case, what we have doing is that the UFO will be flying in air. Obviously, it will be flying in air. So we have taken the fluid as air. And by clicking on the air button, you can see that the density is already being settled. So we do not need to calculate the values. We can put, it will be already there in your window. As it is already there, I do not need to change. So I will just click on the close button. So let us move on to the boundary conditions. We have to don't interfere with that cell zone condition as it is not required for our process. Talking about the boundary condition, let us go on to the inlet. As you can see in the earlier mesh, the name selections were done like inlet, outlet, the UFO, the domains. So you can see the inlet phase is selected. So clicking on the inlet phase, I have given the inlet velocity. So the flow is starting from the x-axis, basically in the positive x direction. It will flow in positive x direction. So the positive x direction magnitude is 20 meter per second. So it is 20 meter per second, and I will just clicking on the apply button. So the inlet velocity will be basically 20 meter per second. Talking about the outlet, we do not need any velocity to the outlet. So we are just giving the gauge pressure to be of 0. So it is 0 and we will just apply, we will not interfere into these conditions. Basically, it is a basic geometry, basic setup. It's very fun to watch and see things. Now our boundary conditions part is completed. Talking about the next reference value, where do we need to compute it? So we need to compute it from the inlet because the flow is starting from the inlet what here we have given. So I will be just clicking on the compute from inlet, and then the reference zone will be the whole fluid domain. Whole domain what we have made in the name selection, what we have named in the selection as it is there, we are clicking on it as a fluid. So as you can see here is that as I click on the inlet, the velocity changes to 20 meter per second and the density is 1.225, which is correct because that are the value we are given. If we were wrong, it will be changing the values. So for this is completed my setup part. Talking about the solutions, the method I am going to use for discretization is green gauss cell based with having a second order upwind. Why I am choosing this? Because I need accurate results and a fast results. That is why I'm using this kind of approach for my simulation. You can use any type. There are 3 types. You can use any one of them. It is basically a solving part. It depends upon your computer. If your computer is a bit slow or fast, it depends. You can change it there. It will be okay for you. Now, talking about the report definitions, what we have added. Now, here is the main, you can see the main part what we have to see. Now, in my case, I have to calculate the lift and the drag. So I have inputted the lift and the drag parameters in the report definitions. Basically, they will give me the values of the report, the values of the result and drag from it. What you have to do just is that you click on the new forces, because lift and drag are the forces acting on the acting on the UFO. So I will be clicking on the forces, and you can see 2 terms, lift and drag. So I will be clicking on the drag just to show you all, because if I create it, it will be showing some errors. So you can see this is, I will be selecting the balls. So it will be, you can see I need to do it around the balls. So it is, I will be selecting the balls basically. So I will be just cancelling because I have already been added it. So close. The monitor factor residue. The residue is meant for a converging factor. If you want your results to be very accurate, you should have a converging factor till about 10 raised to minus 6. As you can see from here, the continuity is 10 raised to minus 6, and everything is converged into 10 raised to minus 6. If the parameters, the scaled residual reaches these parameters, the calculation is converged and it is being completed. So I will just click on the OK button, and then I will be moving on to the initialize. Now I want to initialize it from the inlet. As I have told you earlier, I'll be clicking on the inlet button. As you can see, it is giving only 20 velocities at the x direction, because the fluid is flowing in the x direction. Remaining everything is 0. So I will just click on the initialize button. It will be calculated in seconds, and then run calculations. What I'm doing is, why I'm giving 500 RPM is that is much is sufficient for my convergence in the XYZ velocity. So that much is enough for me. So simply I will be giving 500 iterations, and everything will be remain the same. And just I will be clicking on to the calculate button. Now, as you can see, as I have clicked on the calculate button, it is creating some values here, lift and drag. So it is very difficult to watch it here, and very hectic to watch this console. So we will be moving on to the graphics part, which will be very interesting, right? Because it has plots. These are very great plots. As you can see that because of the aerodynamic of our UFO, the drag is decreasing, the coefficient of drag is decreasing, and the lift will be increasing, obviously. Now, it will be taking for my computation, already it has completed around 4%, but it will take around 15 to 20 minutes to complete the whole iterations. So I will be seeing you in the next, I'll be just skipping it to the solution, the result part, which will be shown by Nuri. Thank you.
As my teammate Dheeraj explained the setup procedure for 0 degree angle of attack, he has run for 20 meter per second inlet velocity and for 500 iterations. Here now the calculation is complete for 500 iterations at 0 degree angle of attack. Now I will show you the results. Here you can see the lift around the UFO, and here you can see the drag. So I will tell you what is the lift and drag around UFO. Now we will go to the report definition. We will go to the drag, and we have selected here drag at walls, around walls, and then drag coefficient. So we will compute it. Okay, and we will see it is printed to console. So here you can see at near walls what is the drag. It is 0.162. Similarly, we will see what is the lift around our UFO. Here we have selected lift, and here we have selected lift, and lift coefficient around the walls. Compute. Okay. Here coefficient of lift is printed, that is 4.134. Now we will see what is the pressure and velocity around our UFO at 0 degree angle of attack. It is main contour. Here you will name as velocity contour. Velocity. We are selecting velocity, and here we are selecting velocity magnitude. Plane it. We have inserted plane, so we can identify the flow velocity around UFO. Compute 7 display. So here you can see in graphs the maximum velocity attained by UFO is 32.5, and here also you can see the maximum compute 7. Here you can see the what is the maximum velocity around, maximum velocity attained by the UFO. It is 32.54. Similarly, we will calculate for pressure. Here we will name as pressure contour. Here we will select the pressure and static pressure or plane it. Compute. Here you can see the maximum pressure attained is 218.1035 Pascal. So we will display. Here you can see in graph the maximum pressure attained. 1 second, I will show you the contour lines. Contour 7 display. Here you can see the contour lines, and for velocity, here you can see how the flow behaves. You see the velocity, the behavior of velocity around UFO. Here you can see. As I have shown the result for 0 degree angle of attack. Similarly, we will calculate for 5 degree angle of attack. I will tell you from which research paper we have taken the reference for our UFO. From CFD analysis on aerodynamic coefficient of flying saucer. It was published in 2021. So our model is similar to flying saucer, but is not exactly same. So we have taken the reference of flying saucer domain. Here you can see the geometry of flying saucer, and our results are similarly same as for 0 degree angle of attack of flying saucer, as we have calculated for 0 degree angle of attack of UFO model. So I will upload this for your reference. I will upload this research paper in our description. Please like, share, and subscribe our channel. Thank you.